An art display consists of an arrangement of n marbles. When arranged in ascending order of mass, the mass of the first marble is 10 grams, then each subsequent marble is 3 grams more, so it'd be 13, 16, and so on, with the rth marble being 7 plus 3r. So the last one is going to be 7 plus 3n, and we're just using that as our final one. Really, this is still the nth term, 7 plus 3r. Show that the mean mass is given by this. Oh, I just want to say one other thing. So there is a formula A plus n minus 1d for the nth term of an arithmetic sequence, which is what we've got here. You might have found other ways to find the nth term. This is covered in A-level maths in the second year, as well as like the summations of series and stuff. I'm going to avoid talking about that. We're focusing on summation notation in this question, and how to use certain results that follow. There's quite a lot of crossover. So the mean is going to be what happens when I add them all up, and that's actually going to be my summation from r equals 1 to n, because that's how many I'm adding up. And actually I'm going to be then adding using the rth term in this, because when r is 1, I'm going to get my 10. When r is 2, I'm going to get 13. When r is n, I'm going to get my 7 plus 3n. So that is my summation. And then I'm going to be dividing by n. Okay, so now to deal with this, you could ignore the limits at this point because it is just from 1 to n. And if you just write that, that's actually what it means. You'll see that in statistics. But I'm going to write it to be really clear. Okay, so what I can do is split the summations up. Instead of doing 7 plus 3r and summing that n times, I can just do these. I can sum n lots of 7, and then from r equals 1 to n of 3r, still divided by n. Then I can change it. I can actually bring the 7 out. So actually I'm just adding, instead of adding up n lots of 7, I'm adding up n lots of 1 and then timesing it by 7. And similar here. Okay, this is the most important one, to be honest. So now I'm adding up. I can bring the 3 out, but r is varying. And I can use standard results now. So this is going to be 7n. I kind of justified it already. We're summing up n lots of 1. So we're just going to get n. And then for this other one, it's 3 times a half n plus 1. Got to learn that one. You can prove it using arithmetic series, which I originally started doing in this video, then I remembered it's on the second year of A-level. So I will actually show a proof without going into the formula from second year, because it's not too bad. This uses the idea. It's worth knowing. Okay, so if I want to sum the numbers from 1 to n, which is what is going on here, I could instead just write them in reverse. And then notice that each pair adds to n plus 1. So I've got n terms that add to n plus 1. I've just got to recognize that I've doubled my sequence because I've actually got the sequence twice here. So I need to have it. And that's where the formula comes from. Look, this is not in the formula book. You need to know this. So be ready to just bring it out. But also, you know, not a bad day to just learn how to derive this. And, you know, in the second year, you derive the general arithmetic series in a similar way. So you might even want to look into that. Okay, why not? Right, I think we're nearly there. So just gonna deal with this. I've got 3 over 2. Let me just check the final answer. How do they leave it? Half 3n plus 17. Okay, so you know what would be a good idea? It would be to just cancel out the n's at this point. So I can just do that. I could factorize out the n and cancel, but I can just chop them out like that. So now I'll get 7 plus 3 over 2n plus 3 over 2. And then they factorize the half out. So I can do that. Why not? Half 14 plus 3n plus 3, which gives me a half 3n plus 17, which is the result that we wanted to get. So now, given that there are 85 marbles in the display, use the standard summation formula to find the standard deviation, the mass of the marbles, giving our answer in grams to 1 decimal place. Nice, linking in statistics into this. So I'm going to first of all go for the variance because it's just a little bit easier to calculate and write down. I don't need to bother writing the square root. I can just say the standard deviation squared. Right, in general, if you've got a list of x, is the mean of the squares minus the square of the mean. So for us, it's going to be the sum from, I'm going to put the index in now. You don't tend to do that in stats, but it's r equals 1 to n. And then for us, it's going to be, well, they've got 7 plus 3r, but we're going to write it as 3r plus 7 all squared over n. We are going to be putting in n equals 85, but it's going to be best to work in terms of n to start with. And then I'm going to be minusing the square of the mean. And remember, we worked out the mean, so it's going to be a quarter 3n plus 17 squared. I'm going to work this out generally and then sub in 85. So I think it's best to just focus on the 3r plus 7 all squared. This will become the sum of 9r squared plus 42r plus 49. And we're going to do a similar sort of thing now. So 9 times the summation of r squared plus 42 times the summation of r plus 49 times the summation of 1s. Okay, and the formula for r squared is 1/6. This is actually given in the formula book, but do learn it. 1/6 n plus 1, 2n plus 1. And then I've got plus 42 times a half n plus 1, just like before, plus 49. We could sub in 85 at this point. I think it's best to, I mean, I'm not going to fully factorize it and things, but let's just simplify it first. So 3 over 2 n plus 1, 2n plus 1, plus 21 n plus 1 plus 49. So therefore, the variance is going to equal, now remember, I'm taking this and I'm dividing by n, so it's going to be 3 over 2 times m plus 1 to n plus 1, just cancel out one of those n's. I've just realized the last bit, oh, I made a mistake. So when I did the summation, I just completely forgot about the n. Quickly notice that. So there should be an n there. Okay, yeah, and I'm all right. So then it's plus 21 n plus 1 plus 49. And then, remember, I'm minusing a quarter 3n plus 17 all squared. Okay, and that's as far as I'm going to take any kind of simplifying. So for n equals 85, you can sub in. So I'll deal with the first bit all together, I think. So it's going to be 86, and then 2 times 85 plus 1 plus 21 times 86 plus 49, 23914. So that is the mean of the squares. And then for the mean, I've got a quarter times 3 times 85 plus 17 all squared. Gives 18,496. subtract these. Gives me 5,418. Remember, that's the variance. So now I'll find the standard deviation by just square rooting. 73.607, which will round to 73.6 grams. So slightly different question here. The first thing you gotta, do, the challenge is to like write down, not just give it, not just ask the sum summation formula that's already like some summation sign that's already given. You have to construct it yourself for the mean and then later for the variance and then this or the standard deviation. This extra bit that's creeping in is that we have some stats, coming into it. So you have to realize, the formula for the mean and the variance. Overall, good question. Well done on your efforts.